Okay, so in this video, we are going to be rationalizing denominators of expressions that have radicals in a denominator. So we are going to use the idea of the conjugate of something to multiply. So notice that conjugates have opposite signs here, and the factors of a difference of squares are conjugates. And so we're really creating a difference of squares. So what we're looking at is our denominator, and whatever sign is between the two terms, we're just changing that sign and multiplying by the rest being the same expression. So we're going to multiply the numerator and denominator by 2 minus the square root of 5 so that we will get rid of the denominator's radicals. So for this one, we had a positive in the middle, so we changed it to a negative. Notice in B, there's a negative in the middle, so we're going to change that one to a positive to write the conjugate. So when I'm doing this, I'm multiplying. So to multiply rational expressions together, remember that I multiply the coefficients, and then I can multiply radicals together if they have the same root. So I'm only multiplying in the numerator. So my numerator is being multiplied by 1. So that's not going to change. So 1 times 2 is still 2. And 1 times negative 5 is still negative square root of 5. And so those values are not changing in this step because I'm multiplying by 1. Notice I won't be multiplying by 1 in B, so they won't change, or they will change there. So the idea of this difference of squares is that by forcing this conjugate, I'm forcing it to be a squared minus b squared, where a and b are the number that I was adding and subtracting each time. So in the original expression, a was 2, right? Because I had 2 plus radical 5. And then I had radical 5. Notice I'm not taking a plus or a minus. It's always positive. So those two numbers, when I plug them into this difference of squares formula, will always be positive. So since I forced this to happen, I don't have to multiply out all 4 terms because the whole point was that the 2 radical 5 and the negative 2 radical 5 will cancel out. So my numerator is still 2 minus the square root of 5. And then I'm squaring 2, so 2 squared is 4, minus the square root of 5 squared, the square root and the square cancel, which was our whole point of this, was for that radical to disappear from the denominator. We've got just 5. So my numerator are not like terms, so 2 minus square root of 5 is still going to stay exactly as it is. It's just carrying on every step. And then 4 minus 5 is negative 1. Whenever I have a denominator that is a value, I want to split up my numerator with my denominator. So I want to take my 2 and put it over its own negative 1, minus radical 5, put it over its own negative 1, so that I can simplify these. So whether it's because it's a number that reduces, or in this case, it's just a sign, that tells me that I'm going to change the sign of the 2 to become a negative 2. And I'm going to change the sign of the radical 5 to become a positive radical 5. So the answer for this problem is negative 2 plus the square root of 5. In part B, our denominator is 2 minus the square root of 3. So that means that we want to multiply by its conjugate, 2 plus the square root of 3. So again, I'm just changing this sign in the middle to become a positive so that I can get that difference of squares in the denominator. So the numerator, though, is a whole different story. When I multiply these, because I have 2 different binomials, I am going to have to multiply everything through. So when we're multiplying 5 times 2, that's 10. 5 times radical 3, we're just going to write the 5 as a coefficient. So since the 5 is not in a square root, I cannot combine those and multiply it to get some kind of 15. Okay? So that 5 just becomes the coefficient. I have to go back and multiply through the negative radical 2. So negative radical 2 times 2 is going to be negative 2 radical 2. Again, I'm not combining that to make a 4 because the second 2 is not inside of square root. But in the last one, I do have 2 of the same type of radicals. So negative radical 2 times positive radical 3 is going to be minus the square root of 2 times 3. So my numerator has those 4 terms right now. We'll come back and simplify afterwards. Remember that our denominator is always the first number squared minus the second number squared. And the whole purpose of this is so that our radical disappears. So we have 2 squared minus the square root of 3 squared, which means that our denominator is going to become 4 minus 3. So 2 squared is 4. The square root of 3 squared cancels the radical, and it's just the radicand of 3. For our numerator, we want to see if we can simplify and combine anything. So 10 is just 10, so that's not going to do anything. This radical is 2 times 3, so this is really a radical 6. So if I think about that, I have a radical 3, a radical 2, and a radical 6. They all have the same index of 2, but every single radicand is different, which means that I cannot combine anything. So my numerator is just going to be 10 plus 5 radical 3 minus 2 radical 2 minus radical 6. My denominator, when I subtract 4 minus 3, that equals 1. So that means that my denominator can go away because I don't need to write a denominator of 1. So again, if that was a number where I could reduce things, I would split everything up. But since it's a 1, I can just drop it. And my answer is 10 plus 5 radical 3 minus 2 radical 2 minus radical 6. Oops, I wrote radical 3 minus radical 6. Okay. So again, our goal is really just to have a single number or nothing in the denominator. So it won't always happen where we have these expressions without denominators when we're rationalizing. All that we care is that there is no more radical in that denominator.